Good morning. Today we are going to see how to design the two element matching network for the given ZS and ZL. So here ZS is given and ZL is given. In order to compensate the mismatch between these ZS and ZL, we have to design the matching network by using two element. So here the characteristic impedance is given Z0 is equal to 50 ohm. If it is not given, you can take the ideal value of Z0 is equal to 50 ohm, right? So if it is given, you can take the given value. Otherwise, you can assume that Z0 is equal to 50 ohm and the frequency is also given as 2 gigahertz, right? So what are the steps we have to do? First, we have to take the value of ZS and ZL from the given problem. That ZS and ZL given in the problem, it is unnormalized value. So first you have to convert that into normalized value. So the first step is converting the unnormalized impedance into the normalized impedance. So to do that, for the conversion, you have to divide the given unnormalized impedance by the characteristic impedance of Z0, right? So here in this problem, the Z0 value given is 50. So to convert ZS, that is the unnormalized value, capital ZS, into the normalized value, that is small ZS, you have to divide the unnormalized impedance by characteristic impedance 50 ohm. So ZS has to be calculated first. Similarly, ZL has to be converted, right? So capital ZL is a given in the problem, that is equal to unnormalized value, that you have to convert into normalized value by dividing the given capital ZL by Z0, that is 50, it is given out in the problem. So you have to convert into ZL. So first step is to find small ZS and small ZL, that are all normalized source and load impedances. So by having ZS and ZL, you can calculate the YS and YL, that is equal to the reciprocal of impedance, right? YS is equal to 1 by ZS and YL is equal to 1 by YL, right? This is the first step. After calculating ZS, small ZS and small ZL, you have to find ZL star, because we are going to find the matching network. So in order to design the matching network, so what is the benefit of matching network? It will give the maximum power delivery. So according to maximum power transfer theorem, so if the source impedance is equal to the reciprocal of the complex conjugate of the load impedance, then only you can have the maximum power transfer. So ZS should be equal to ZL star. So that's why we have to calculate ZL star also. How to calculate? So ZL you can calculate by the given value, that is given value divided by 50, it will give the ZL. So ZL is, so whatever ZL we have, in that you have to change the polarity of the complex part, right? So here it is 0.5 minus J1. So ZL star, that is equal to 0.5, this minus should be converted into plus, so 0.5 plus J1, right? So this is completing the first step. And second step, after the calculation, you have to mark the ZS value and ZL star value, right? So this is the ZS value, this is the ZS value, this ZS value and this ZL star value, you have to mark it on the Smith chart. So how to mark it on the Smith chart? So here this is the resistance scale, this is the resistive part scale, and the reactance part scale is given here. This is the reactance value, right? So whatever the reading we have in the inner circle, right? So below the inner circle, that gives the reactance value. So if it is above the impedance in the upper half part of the Smith chart, then it will give the inductive reactance, and if it is in the lower bottom of the lower half of the Smith chart, right, it will give the capacitance value. For example, if you want to fix 1 plus J.5, it is equal to 1 is the resistance and J.5 is the inductive reactance. So 1 you have to mark in the horizontal scale, this is the 1.0, so this is the resistance point, this is 1.0 resistance point, and 0.5 you have to mark by using this reading, right, in this reading. So here ZS it is marked here, right, ZS it is marked here. So this is the 0.5 scale, here where you will be having here 0.5. So here if it is, for example, if this is a point by arc means you have to trace this arc in one finger and the next finger you have to trace from here, right? So here from you have to trace and here you have to trace and you have to find the intersection point between the two tracing. So this is the inductive element tracing and this is a resistive element tracing, right? So this arc and this arc should be intersect at one particular point. That point is called as ZS point. ZS equal to 1 plus j point pi. Similarly, you have to mark ZL star also. ZL star is equal to 0.5 j plus 1, I think so, right? So ZL star is equal to 0.5 plus j1 actually. So 0.5 you have to mark here. So 1, 0.9, 0.7, 0.6, 0.5. So this is the value of 0.5. So 0.5 arc you have to project here, and similarly 1 arc you have to project from this inductive reactance. So you have to find the intersection point between the one resistance arc and 0.5 inductive reactance arc. So that will meet at one point, that will give the ZL point. So this is the point where we have ZL. So after marking ZS and ZL, you have to trace the circles which pass through the marked impedance value. So ZS you have marked, no? So by through this point you will be having one resistive circle and one G circle, one R circle and one G circle. R circle it is called as resistive circle and G circle it is called as the conductive circle. So this is the point ZS. So from through this point this is the R circle, right? So this is the R circle and this is the G circle. This is a G circle. Similarly at ZL point our through this ZL point also you will be having two circles. One is the R circle. This is the R circle. That's all the clockwise circles are called as R circle and all the anti-clockwise circles are called as G circle. That is conductive circles, right? So through this ZL point, this is the R circle and this is the G circle. So we have marked two impedances. So through these two impedances we have drawn four circles, right? So this is the second point. Drawing tracing the circles which pass through the ZS and ZL star point. This is the second point. After tracing four circles, you have to find the intersection point now, right? What is the meaning by intersection point, right? We have four circles, no? We have to find the intersection point at which one R circle meet with one G circle. That is the meaning. Intersection point of one R with one G circle, right? So here I have marked A, B, C, D, right? So I have marked as A, B, C, D, right? So this is a first intersection point between this G circle and this R circle. So if you fix the intersection point just below that parallelly, you will be having one more intersection point, that is B here, right? Similarly, another two circle. This is the another intersection point between this R and this G. So if you mark this at this place parallelly at the bottom, you will be having one more intersection point. So A, B and C and D all are four intersection point. After marking this four intersection point, you have to find the value of impedances at the four intersection point like this. Z is equal to 0.5 plus 0.6. So how to find the impedances? For example, if it is A, right? So this is the intersection point. You find the resistance R through this A, right? So this is the value of R, right? And similarly through this intersection point we will be having one inductive arc. This is the inductive arc. So at this point what will be the value here? That will give the inductive arc. So 0.5 plus j.6. Likewise you have to find the impedances value through the four intersection point, right? So this is the second step, right? So third step, once you have fixed the intersection point is at A, B, C, D, you can draw the matching network element by tracing the path, right? So how to trace the path? Here this is the path, for example. So to trace the path, you should start from the source impedance and the path should be completed at the ZL star, right? All the tracing should be starts at the source impedance and it should be completed at ZL star through one intersection point. Since in this problem we have four intersection point, we can able to draw four different matching network, one for each intersection point. For example, if it is at the intersection point A means it should be start at ZA. Followed by it should start at the source impedance, go through through ZA and it should be ended with ZL star, right? So how to trace that path, right? So ZS, here it is ZS, right? So here it is ZL. So the tracing path should be started at ZS and it should be completed at ZL, but it should flow through any one of the intersection point. For example, A point means so like this. So the tracing path is ZS start and it go to A, then it should complete at ZL, right? So here this is the one arc between ZS and ZA, and this is another arc between ZA and ZL star. So this arc will give one element and this arc will give another element, hence this is two element matching network. So how to find this is whether it is an inductive element or capacitive element, right? So this is one element, it can be C or L. Similarly, this is another element, it can be C or L. So how to find whether this is C or L, right? So to find the nature of the element, you should see two things. One is the direction of the arrow or the direction of the path, tracing path, and the type of the circle in which the path is traced, right? These are the two parameters which should be decided the nature of the element. For example, you take this path. So here this path has been traced through the circle, that is the conductance circle, G circle, right? So this is a G circle. If the particular trace is through the G circle means, then the element will be shunt, right? So the path is through the G circle, it is shunt. Through the R circle means the element is in series, right? That is the concept. So shunt and series can be decided by having the path whether it is in the G circle or R circle. If it is in R circle, then it is series. If it is in G circle, then it is shunt, right? Then, so we have found series as shunt, whether it is L or C, that is whether the element is inductance or capacitance, how to find, right? So you have to check the direction of the trace, right? So here, so we have started at ZS, so we have followed like that, so upward, that's why the arrow is upward, and then from A point we have to end it with ZR, so again it goes upward, right? So by putting this arrow properly, you can able to decide whether the element is L or C. If the arrow is upward, then it is L, right? If the arrow is upward through the trace path, then it is L. If the arrow is downward, then it is C, right? So for this A point, the matching network consists of two elements. One is the element for this arc and the another element is for this arc. This element goes on G circle, that's why it is shunt. The arrow is towards upward, so it is shunt here. Similarly, for this arc goes through the R circle, so it is series, and arrow is towards upward, then it is L. So series L and shunt L. So the matching network through the intersection point A consists of two elements. So both are L, that is shunt L and series L, right? So this is the arc for shunt L and this is the arc for series L. This is G circle and this is R circle, both the arrows are towards up, that's why it is both the elements are L. So this is the G circle, that's why it is shunt, this is R circle, that's why it is series. And this is the source impedance and this is load impedance, which we are going to match by using this matching element, which consists of the combination of the two inductors in series and parallel, right? That's all. So similarly, you have to find the two elements in each and every intersection point. For example, if it is B, right? You take the B intersection point. What is the condition? You have to start from ZS followed by B intersection point and you have to enter at ZL, right? So the arc for B intersection point is ZS is the starting point and it goes through B and it should be entered through ZL's point. So the one arc is like this, right? And the another arc is like this. So this arc will give one element and this arc will give another element. What is the element here? So this is the circle for G circle, right? So this is G circle, so it is a shunt element. So the arrow is downwards, so it is C. So this arc will give shunt C. So that's why I have written shunt C here. And what is the element for this arc? So this is the circle for R circle. So it is series. right? And this element and the arrow is also towards upward, right? So towards up means it is L, so it is series L. So the intersection point B will give the two element matching network, which comprises of one series L and one shunt L, right? That is the meaning, right? So this is the diagram for one shunt C and series here, right? Likewise, you can able to trace the point in each and every intersection point. You can have 4 different circuits like that. Then last step is how to calculate the value, right? So we have identified the nature of the element, whether it is LRC or whether it is in SUNT-RC. Then how to calculate the element value, right? So to calculate the element value, again you have to take the two impedances which will give the starting and ending point of the path, right? So here we have taken, so this arc will give one element and this arc will give one element. No, so at this point you will be having one impedance and at this point you will be having one impedance and at this point you will be having one impedance, right? So this is the two impedances which give one element and this is the another two impedances which will give another element. So by using that impedance value you can able to find the value of the component, right? So for example, so for intersection point A, circuit A, this is a trace point. So ZS and ZA give one element and ZA and ZL star will give another element, right? So if it is the series, if the element is series means you have to take the ending point impedance minus starting point impedance, right? If it is shunt elements means you have to take starting point impedance minus ending point impedance, right? So you have to calculate. So for example, this is the two impedance for the particular component now. So this is starting point impedance, this is the ending point impedance. If the element is series means you have to take ending minus starting, that is ZA minus ZS. If it is the shunt means you have to take starting minus ending, that is ZS minus ZA, right? So likewise you have to substitute the value and you have to simplify that to find the value of this one, right? Then you have to do the scaling. So to do the scaling, if it is inductance means you have to multiply by Z0. If it is capacitance means you have to divide by Z0. That's all, right? So here I have written the hints for calculating the elements value. If it is series means you have to take ending point impedance minus starting point impedance. X is equal to omega L, omega is equal to 2 pi FL. If it is shunt means you have to take a starting point impedance minus ending point impedance and you have to consider X is equal to 1 by omega C, that is equal to 1 by 2 pi F into B. And for scaling, if it is L means you have to multiply by the characteristic impedance Z0. If it is C means you have to divide the value by the characteristic impedance Z0. If the Z0 is given in the problem, you have to take that given value. If it is not given, you can able to assume that Z0 is equal to 50, that is the ideal characteristic impedance. So this is the last steps to design the matching network. After finding the values of all the elements, you can substitute the values of elements in respective circuit, right? So this is a circuit diagram, right? So if you find the values exactly, all inductance value will be in the nanohenry and all the capacitance value will be in the picofarad, right? This is the detailed procedure how to find or how to design the two element or L section matching network for the matching of the source impedance and the load impedance. Thank you.